Okay, so the previous video we saw that we can't solve this unless they give us another equation. The reason for it, because there are two variables. The answers here are infinite if I didn't give you this piece of information. But here I'm giving you more information. Now, there's two main ways how we can solve this. Usually in the IG exam, they'll ask you to do it algebraically, so doing kind of calculations, etc. But sometimes it does pop up that you have to do it visually. And understanding that you can do it visually, or well, not visually, more like graphically. Graphically would be on a graph. It's important that you understand how this works. Now, these two are actually functions. We can actually write them as straight lines. Now, there's different ways for us to draw this. There's the table method, there's the dual intercept method, and the intercept gradient method. There's probably other methods too, but those three are the ones that you should have learned or know by now. And I'm not going to go into how to draw straight lines now. I'll put a link in the description below where you can go and find the video where I explain exactly how to do it. Again, you can use either of the methods. I'm going to use the dual intercept method because my 0 times table is amazing. I have been practicing it all my life and it's great. I can multiply anything by 0 and I'm pretty good at it. So I don't really like doing tables or anything, but the important bit here is if they give us two functions like this or two equations and they say solve simultaneously graphically, it means that I will need to actually draw a little graph or have a little graph and draw these two straight lines. Okay, so let's start off with this one. So you should know that if I'm following the dual intercept method, so if I want to get my x-intercept, I'm going to make y 0. And if I make y 0 in there, let me just rewrite it all nice and color-coded. Put the y is equal to 0 in there. That's my 0 is equal to 4. And then I can see, well, x is just going to be 4. So for my x-intercept, I can go here and look for x is 4, and that's going to be there. Make a little dot there. And for my y-intercept, guess what? I'm going to make x 0. And I'm just going to put, okay, sorry, let's do a little line here. There we go. The y, I'm making x 0 this time because I'm looking for my y-intercept. And, oh, wait, I'm just confusing the colors. Sorry, guys. There we go. Plus y is equal to 4, and then y is just equal to 4. Very straightforward. So I'm going to look for y is equal to 4. And I don't know, do I have a ruler? Yes, I do. I have a ruler. And I'm going to draw the line right over there. Okay. Quickly label this one. Say this is x plus y equals 4. Okay, so I drew that one. And this line, I actually already know what it looks like. So x is equal to y, y is equal to x. You should know this one. Every x coordinate and y coordinate is going to be the same. So basically 0, 0, 1, 1. It's a diagonal line, 45-degree angle if the scale is kind of the same. So let me just get this straight, underlined, kind of, there we go. And this one is y is equal to x, so x is equal to y. Cool. So we see something special. Ooh, this doesn't look so nice now. Let's just take this off. There we go. Okay, so what I've done is I've drawn both my lines, and the simultaneous equation is like the question is like, where are both true, I guess, if you can say it like that. And they're both true at this little place where they cross. And I can read the x value here. The x value is 2, so x is equal to 2. And the y value is actually also equal to 2. Obviously it has to be because x has to be equal to y. But now I can see if I were to fill in 2 there and 2 there, I would get 4, so that would work. And 2 is also equal to 2, so that would work. So in this case, I had to draw the lines and find where they cross. Now this is very, very important. Later on in the course, we're going to give you a straight line and a parabola actually. So there will be a straight line and there will be a parabola, and they're actually going to cross at 2 places, and we're going to look at that. But the point you should understand is that whenever we get 2 equations, we can solve them simultaneously by drawing them and then just checking where they cross. Then we're going to look at other different ways as well, but let's just do baby steps for now. So this is the one example. We're done with that one. Put it aside, and let's take a look at another one. So you should maybe get some graph paper. Maybe I should put a link somewhere for graph paper, but let's take a look at our next example. So y is, oh no, not y is equal to, y minus 2x is equal to 2. That's our one equation. And the other one is y minus 3 is equal to x. Now, again, they can say solve this simultaneously. And if they don't say anything, then you can either do it graphically or you can do it algebraically, but we'll still look at how it works when we do it algebraically. But for this one, we're going to do it graphically because that's the title of the video, so I'm going to need a little graph. I can use different methods, but I'm going to use the dual intercept. You know why? Because I'm good at my 0 times table. So let's say for my x-intercept, I'm just going to write x-intercept. I'm going to make y 0, so I'm just going to rewrite this. In there I'm going to put a 0. Minus 2x is equal to 2. So I'm going to divide both sides by -2, and then x would be -1. Sorry, what did I do? X-intercept. Yeah, y is 0, x is -1. Okay, so let me just go find -1 on here. We'll do this in blue, this one. Okay, there we go. X is -1. And then for my y-intercept, I'm going to make x 0, and it's kind of nice because that whole thing is just going to disappear. It's going to be y minus 2 times 0 is equal to 2. You don't even have to write this out. I'm just doing it for the sake of the video, for those that need to brush up their skills on drawing lines. But I just end up with y is 2. And then y would be 2 right about there. So let me, oh, where did I put that ruler? There we go. Hello, ruler. Very mean ruler, very heavy ruler. Okay, there we go. Nice. Draw that. Hope it's accurate enough. And then on this one, we're going to do it in red, and I will do the same thing. So for my x-intercept, I'm going to make y 0, and if y is 0, then you see x is -3, right? Okay, x is -3, so x is -3 right over there. And then for my y-intercept, you can see how quick this is. If I had to draw a table or do standard form, it would have taken a lot longer. Y is 0, oh sorry, x has to be 0. Just right there, x is going to be 0 to get my y-intercept. X is 0, so I get y minus 3 is 0. Y is equal to 3, and then I'm just looking for 3. And then I'm going to draw a line. Now, hopefully, I did it well enough that we can find where they cross. Let's just see. Okay, those are my 2 lines. And, okay, let me label them. Okay, so the red one was y minus 3 is equal to x. And the blue one, I'll just label it this side, y minus 2x equals 2. Okay, and you can see I didn't do it great. They should have actually crossed there, but that's where they cross. And this is another point I want to make, is that when we do things graphically, we don't always get like exact answers. Sometimes these would cross on fractions, so it might be a 1 point, they cross like at 1.1 and 2.3 and things like that. So then it's going to be very difficult to read that off a graph. These two examples I chose because they should have been easier to draw, but you can see I kind of missed it there. But let's just see, if I take these coordinates where they should have crossed, if I did it like very nicely with a good ruler, I guess, and taking my sweet time like you will do in your exam, obviously, I would have x as 1, so x would be 1, and y would be 4, because this is where they cross. And let's just check if this, if I fill it in here, if these things actually work out. So I'm just going to rewrite this. Y minus 2x is 2. So if I were to make x1 in here, this is now my test. And then rearrange, that would be y minus 2 is 2, and then y goes over 4. Wow, look, I got to 4. And in this one the same. If I were to put in x is 1, so y minus 3 is equal to 1, and then y is 1 plus 3, and then y is 4, you can see that I got to the same answer. So the x and y coordinates at that point is going to be the same for both of these lines. So this is how we solve this graphically. In the next video, we're going to look at how we can do it algebraically. And algebraically will obviously be 100% more accurate than graphically, because you can see I kind of missed the mark. It should have been, I don't know if you can see that, it should have been there, but I just missed it with my very thick markers and ruler.